All right, so this one we're supposed to do the same thing, find the domain of the rational function. We don't have to find the range, we just have to find the domain. Now with domains, on this, since we have a rational function, that means we have to find the denominator. And so what we're going to say is, well, if we set that denominator equal to 0, then what we get is, now we're, I think, a minus 1, subtract x equals a negative 1. So at x equals negative 1, we get 0 in the denominator. Well, we can't have 0 in the denominator because we can't divide by 0. So this means that x cannot equal a negative 1. If it does, we're going to get 0 and it fails. And so the domain is going to be all x except for x equals negative 1. So it's all the x's except for that one. And another way to write that is we're going to go from negative infinity up to negative 1 union negative 1 up to positive infinity. And this here break with the parentheses means it doesn't equal 1. And so it's all x's except for that one. So that's going to be all x's except for that one. Okay. How about this one? Same kind of concept. We're going to basically solve the denominator and figure out where zeros occur, and where those occur is where they can't have x equal. And so y squared minus 5y. So what I see is I see a factor of y in both of those. So if I factor out a y out of both of those, I get y minus 5. And now what I can do is I can say, well, let's set each term equal to 0. So y equals 0 and y minus 5 equals 0. Well, if I add 5 here, y equals 5. So that means when y is equal to 0 or when y equals 5, we get 0 in the denominator. So here it's going to be all x except x equals, or I guess these, well, in this case it's y, I guess we were using y equals 0 and it's all y and 5. So how are we going to write that one? Well, our domain is going to go from negative infinity up to, now we can go up to 0, that's the first one, union 0. Now we're going to go up to 5, but we can't include 5, union, and then 5 all the way up to positive infinity. So here we exclude 0, and here we exclude 5, because if theirs are equal, we get 0 in the denominator, so we cannot have that. So all the y's except for those two are going to be possible. All right, let's stop there and we'll come back for some more.